So, for the last, as for the last lecture for today, we'll talk about a technology which probably everyone here has used, databases. And imagine it or not, they're much more than just storing usernames and emails in just normal CRUD data. They can do a lot more than we can expect from them. And that's what Mikaël Francoeur will talk to us today about. Let's give him a round of applause, please.
Awesome. 1, 2. Thank you very much, everyone. My name is Mikaël Francoeur. I'm an independent software engineer from Canada who just happened to be in Bulgaria while OpenFest is happening. So really nice coincidence. I'm super happy to be here, and I'm super happy to be talking about SQLite, because today what we're going to talk about is not just SQLite. We're going to talk about what more it can do than just simple CRUD queries. So CRUD is create, read, update, delete. It's what you usually do with a database. But today we're going to see all of the other things that are enabled by SQLite's fairly, actually pretty amazing extensibility. So we're going to look at HTTP requests, vector search, synchronizing databases, and we're also going to look at all of the little open source projects that form a nebula of communities and projects around SQLite. Are you ready? Are you hungry? Oh, that's good. I was expecting a much more yes or much more positive answer than that. Cool. 5 o'clock is like pretty much dinner time in Canada. All right, so just so we're off to a good start and we're all starting on the same page, SQLite is an embedded database, which means that it's a library that you use in your application. So it's not a separate server that you call to like MySQL. It's a library, and that library is going to talk to either an in-memory database or a file that's most often on disk, and that file is going to be your whole database. So SQLite, basically a library that allows you to manipulate a file with SQL queries. It's public domain. It's not even licensed Apache or MIT or one of those licenses. It's literally public domain for everyone to fork, use, and enjoy. And it is ubiquitous. Natively, it exposes a C API, but it's got bindings in pretty much every language you can think of. So if you use Python, you can use SQLite. If you use Haskell, you can use SQLite, but natively, it's a C API. Awesome, and today we're going to talk about SQLite's extension points and how we can use them to our advantage to do cool things. SQLite allows you to extend it by registering custom collations, simple functions, so things like the UUID function. SQLite doesn't have one by default. You just register it, and it's super easy. You call a function called, I think, create function, you name it UUID, and then you pass in a lambda, and then whenever SQLite sees a function called UUID, it's going to call your lambda instead to to execute the UUID function. You can also register window functions, aggregate functions, and super interestingly, virtual tables. And those are tables that are not going to be backed by data on disk, like a regular table would be, but they're tables that will be backed by an application or an arbitrary library or an arbitrary piece of software, but yet SQLite will still treat them the same as it would any other table. So that enables some really powerful stuff that we'll look at today. And then finally, you can register custom virtual file systems, and that's a way that you can swap out the storage layer in SQLite. Internally, they use it for testing, so the SQLite team uses it for testing. They use it for things like fault injection. But one use case we'll look at later today is a very clever one, and I'll keep the suspense going for now until we get there. So the first extension I want to get to is vector search. Vector search is very much adjacent to AI. I'm sure you've all heard of AI. Do we need to go over AI? Okay, awesome. So vector search, if you're not aware of what it is, it's a fancy name for semantic search. And if you're not sure what semantic search is, it's another fancy name for searching by meaning or by intent. And an example of that is if I have a store online and I sell vacuum cleaners, and one of my users enters into my search bar cleaning supplies. Well, chances are that if I do a substring match to search through my inventory for cleaning supplies, I'm not going to find vacuum cleaners because, presumably it's not in either the title or the description of the item. But there's a way that we can feed both the vacuum cleaners and the user's search string to a machine learning model and say, what is your opinion, or what is a machine's internal representation, internal semantic representation of this? And we call this a vector. It's just a very large array of numbers. And then once we have all of the vectors, we can do some fancy math that I don't understand completely, but it works. And what that math is going to do is it's going to say, is the phrase cleaning supplies moderately similar to anything that I have in my inventory? So it's going to look at cleaning supplies, it's going to look at the vector for that, it's going to look at vacuum cleaners, it's going to look at the vector for that, it's going to say, are they in their hyperdimensional space somewhat similar? And if so, then, well, I'll have the opportunity to maybe show vacuum cleaners to a user who wants to buy cleaning supplies. There's two extensions that are going to allow us to perform vector search using SQLite. The first one is SQLite Vec. It's by a guy named Alex Garcia, who did a ton of interesting SQLite extensions. It was sponsored by Mozilla during its development. It's still in alpha, and they call it fast enough, and there's no recent commits, which doesn't mean anything by itself. And secondly, there's another extension called SQLite Vector. It's by a company called SQLite.ai. It's supposedly very optimized, and it's still in active development. So without further ado, let's go to my IDE here. I'm using NeoVim, so if you're mad that I called NeoVim an IDE, then we can talk about it later. But I have this folder here called Vector, and it contains one simple application. This application is in Rust, but please do not run away. If you can't read Rust, that's totally fine. That's not the point of this talk. The point is business logic and what you can do with SQLite. So I'm going to walk you through it, and it's a fairly short application. And I'm thinking, is this big enough? Do I need to make the font bigger? Good? Awesome. It's okay. I heard it's okay. Is this better? Okay. Good. So you'll see that this application is 112 lines long. And what I did is I imagined that I have a library of software engineering books. And those titles here, those 12 titles are the titles of books on software engineering. And you'll see that I have things about React here. I have things about CSS. I have things about transformers, Kafka, Spark. And if you'll notice, if you have a really keen eye, I don't have the word database in any of these. But presumably, I would like to query my book library, my library, and say, do I have any books about databases? And of course I do. There's even one here about Postgres, second last. It just doesn't have the word databases in it. So what we can use for that is vector search. So I'm going to walk you through how this works, and I'm going to skip some boilerplate because there is some boilerplate and it's not so interesting. So the first thing we do is that we're going to register the SQLite Vec extension. Let me jump to the function here, and it's not working. Yes, it is. And this here is just copy-paste from the documentation, so nothing too complicated here. And then the next interesting thing is we're going to open an in-memory database. And as soon as I do that, I have access to an in-memory ephemeral database that I can perform regular SQL on. I'm saying regular, but I can do more than that since I've already registered the SQLite Vec extension. And the next thing I'm going to do is I'm going to create a table, except that I'm not simply going to say create table. I'm going to use a small extension from SQLite. I'm going to say create a virtual table vec demo using vec0. Vec is simply the internal name that this extension happens to have. And then this line here simply says we're going to store an embedding, so a very large array of numbers in here. Again, this is almost copy-paste from the documentation. And we're also going to store the titles of our books. The next thing we do is we iterate through all of our titles. For each of them, we're going to extract an embedding. So we're going to ask a machine learning model, what's your idea of this string? It's going to give us a long array of numbers, and then we're going to persist this into our SQLite database using, again, plain SQL. And then finally, we're ready for the magic trick here. What we're going to do is we're going to take our query here, we're going to get the embedding from that, and we are going to perform what's called a KNN, or K nearest neighbor search. In this case, we're going to ask for the eight nearest vectors that we have in our database, and therefore it's going to return the eight most relevant books that I have. So let's see how it works. Let me go to my terminal. There we go. And just before I do that, I forgot that I have to have Olama running, so I'm just going to start it in another tab. There we go. It's now running, so I have a small server running on my computer that will respond to the query, what is the embedding of this string? So let's cd to the vector folder. I'm going to do a cargo run on this. You'll see it's not going to do anything, or it'll do something broken because I forgot to pass in a query. But if I pass in the word databases, you'll see that I get Postgres, Kafka, Spark. I'm pretty happy with that, right? To me, this is a good semantic search. It was performed in SQL using SQLite. And what's interesting is, let me go back to my application here, is since everything we did is in SQL, I could have joined this with something else. I could have performed aggregations. I could have said, what's the average price for the top five most relevant books in my library. I could have inserted this into something else. So really, the world is your oyster. Since we're in SQL, we can do everything that SQL would do. Another example why you might want to do this through SQLite is, for example, if you're developing a local-first application, let's say a note-taking application, and you want to let your user search their notes and say, do I have anything about I don't know, angry people here, or do I have anything about contract renewals? And then you can expose that functionality mobile first on a phone, on a tablet, and people will be able to perform semantic search over their personal documents. Awesome. So that's it for SQLite Vec. Now let's look at another, it's actually my favorite, another very interesting thing we can do with SQLite. We're going to look at doing HTTP requests. Now, why would you want to perform HTTP requests with a database? It makes absolutely no sense. Well, it kind of does. It makes a little sense, and I hope I'm going to be able to make my point, and that by the end of this little demo, you'll see the value that there is in doing these kinds of things. So we're going to use an extension called SQLite HTTP. It's, again, by Alex Garcia. He's kind of the extensions guy. He did a lot of them. It's pre-V1, and there's no observability, so please do not use this in production. But it can be good for rapid prototyping, exploratory work. You can see it exposes a nice declarative interface when you're dealing with things like REST APIs. So it can be good for rapid prototyping, and especially LLMs are fairly proficient at SQL, and I found that this proficiency also transfers when you're using things like extensions over SQLite. So maybe this will be a surprise to you. This is actually a good fit for pageable extensions, or excuse me, for pageable APIs, because SQL natively, so in the SQL standard, SQL supports recursion. So you can declare recursive common table expressions, and therefore query recursive data structures and things like pageable APIs. So let me show you how it works. And it's going to give me a good opportunity to show you the SQLite CLI. So terminal, let's cd into the right folder. And I'm going to open up the SQLite CLI. It's called SQLite 3, and just like that, I am dropped into an in-memory database. It's going to vanish as soon as I exit the CLI. So it's really good for fast prototyping. You can also start it using a file as a database, and I'm going to show you how to do that later. So now we're going to make SQLite aware of where the SQLite HTTP extension is. Because if I give it a query that has some HTTP requests in it, it's not going to understand anything. So let me just do this, and it's pretty easy. If I go to the left here, and I go to my HTTP folder, you'll see I have a file called SQLite http.dylib. So I'm on Mac. Dylib is the equivalent of a .so on Linux or a DLL on Windows. Simply a precompiled library. So I'm going to do .load SQLite HTTP, and just like that, SQLite is aware of this extension. Now, let me show you what we're going to do with this. Is anyone here not familiar with Pokemon? Okay, I'm assuming everyone is moderately familiar with Pokemon. So there's this thing on the internet called the Pokemon API. If I go to my browser here, Poke API, there we go. It exposes this resource called /Pokemon, and it gives you a list of every Pokemon there is. And there's a few interesting things about this, and the first one is that it's a pageable API. So if I add a limit 5 to make it a little more obvious, when we query this API, we need to take note of the Pokemon that are returned to us, and then go to this next link, browse it, take a note of those Pokemon, go to the next link, browse it, and etc. until you have enough Pokemon or until you're done. What I'm going to show you is how we can automate this recursive motion of following the next pointers using SQLite. And on top of this, I'm going to show you how we can build a table of every Pokemon with their types. Now, that might sound simple, but let me show you what we need to do in this API to get this result. So let's say I want to do this for 5 Pokemon. I first need to go to the first Pokemon, look at its name, follow this link, then drill down through the JSON, and then coalesce its types. Sometimes it's going to have more than one, so I'm going to say grass, poison. And then I need to do this for the next guy, and the next guy, and the next guy. And that means that if I have 10 Pokemon with a limit of 5, then I'm going to have to do 12 requests. And if you were to script that using curl, that would probably be a nightmare, because you're going to have to deal with loops in Bash and maybe recursion and mutable state. And it's not so complicated, but it's definitely not comfortable is the word I'm looking for. So it turns out that databases are surprisingly good at doing those kinds of things, because the motion of looking at a piece of data and then looking at each row and fetching some data based on the content of each row, in the database world, this is called a dependent subquery. And it's something that relational databases do all the time, including SQLite. So what this means is that if we plug in an HTTP extension into SQLite, we can get the query engine to do all of the heavy lifting for us. So let me show you what it looks like as an SQL query, and this is the query that gives you a bunch of Pokemon with their comma-separated types. And I'm going to make this a little smaller so you can see. It's not as pretty as I would like it to be, but if you consider what you would have to do in a general purpose programming language to get the equivalent result, I think we're better off if we're only doing rapid prototyping or exploratory work. I think we're better off with this, because you have this, and as soon as you want to extend it, then it becomes easy to perform other aggregations or other JSON manipulation, because you have access to everything that a database can do. Make sense? Awesome. So let me run this, and you'll see, surprisingly, how quickly it runs. It's going to need, I think we're going to retrieve something like 15 Pokemon with their types. So we're going to need to do about 20 requests, all pretty much at the same time. So sorry, Poke API. I know that's not super nice for the API, but The way I'm going to do this is I'm not going to copy paste the whole thing, the whole 33 lines into my SQLite CLI. I hate copy pasting things into the terminal. It's never a good user experience. It's hard to edit, and then you end up messing up things. So what I'm going to do is I'm going to use another dot command, and this one is .read, and I'm simply going to give it the file name. So this one is called Pokemon with types.sql, and 1, 2, 3, go. There we go. There's our somewhat close to 15 Pokemon with their types, almost instantaneous. You might say, this is ugly. I don't want to stare at this. Like, there's this weird bar in the middle. It's hard to read. So you just go mode box, so .mode box. This tells SQLite format it in a nicer way, and then you read it again. Again, sorry to the API. We get a nicer formatting. You can also format it as something that's a little more machine readable, something like JSON, .mode JSON. Then we run it again. Now, why would we want to do that? Because we're back to square one, and still ugly, unformatted JSON is hard to read. Well, one of the reasons is that in this CLI, it's super easy to pipe the results of something to a file. So let me show you how you do that. There's a couple of ways to do it, but one is going .once, and then you give it the name of a file. So result.json is going to remember that the next query should be piped into a file in the format that you specified. So I'm going to read this query again. Seems to be taking a little longer. OK, so maybe the API rate limited me. OK, come on. Once result.json demo gods. OK, there we go. And now we have our JSON in our file, and I can format it, and I can do whatever I want with it. So if I go back to my query, today I'm not going to have time to go through the whole query with you, but it's just a simple query with joins and aggregations. In the last slide of my talk, there's a QR code. If you want to look at it, take inspiration from it, there's going to be a QR code with the links to everything and the code from my demos, including this. But for now, what I want to leave you with is the idea that combining HTTP requests with relational databases can sometimes be surprisingly effective for things like prototyping or exploratory work. Awesome. And now I think that I have completely messed up PowerPoint, but I figure everyone can still see this. So let's keep going. The next extension I want to show you is one that's meant for synchronizing databases. And the reason you might want to synchronize databases using SQLite is that when you use a client-server database like MySQL or Postgres, you're going to have various users or clients talking to the same database. And it's that database's responsibility to make sure that everyone is on the same page to keep data consistency optimal. When you use something like SQLite, it calls for a mode of collaboration that's closer to what Git was designed for, where everyone has their own copy on the data that they're working on, and where everyone has a list of peers or remotes that they can push or pull to in order to synchronize themselves or others. So when you do that, you need a way to synchronize databases. And SQLite is able to, very similarly to how Unix does it with Unix patches and how Git does it with Git merge, it's able to reconcile divergent databases. Yes, OK. So the way it works is that you simply open a session, say, SQLite, please start tracking my changes. Then you modify your database, you do whatever you want to it, you work on it, and while you do that, the session extension will keep track of your modifications so that when you ask it to create what's called a change set, it's going to be able to dump a file to the disk, and that file is going to contain a binary representation of all of the changes that have occurred in your databases. And what you can then do with this change set, so with this file, is you can send it somewhere else, and you can then apply it just like you would a Unix patch, or you would do with git merge. You can apply it to another database. It even supports merging conflicts. So if you have two divergent states that have diverged in ways that cannot be automatically resolved, we'll see that there's a way we can deal with that using the session extension. And by the way, all of the extensions we've seen so far were third-party extensions. This one is made by the SQLite team because it's such a core requirement for SQLite workflows. And one common one common pattern where you might want to do this is, let's say you're building an application, a mobile-first application, and one of your users has two devices. They have a phone and a tablet, and they can work offline on those devices. So they work offline on their phone, they work offline on their tablet, and when those devices come back online, then you'll want to sync that state with the server and maybe deal with some conflicts there. So let's go to my terminal and play a bit with the session extension. So I have on the left, I have this folder called session, and what we're going to do is we're going to start from a base state, and we're going to pretend that we're two different people. We're going to pretend that we're A and that we're B, and that both are doing different things, and at the end, we're going to take the changes that were made in B, and we're going to merge them or put them or apply them onto database A so that we can transfer the changes from one to another. Sounds good? Awesome. Let me go to my terminal, quit this, cd into the correct folder, session. What I'm going to do first is I'm going to create a base state. And I'm going to use this as an opportunity to show you how easy it is to load CSV data into SQLite. On the left here, I have this file called base.csv. It contains the data that we're going to use today. So it's 4 rows, and we're going to use this to populate a table. And here's how we do it. SQLite 3, we're going to call our database base.db, and we're going to create a table. And that table is going to contain 2 columns. One, a name. It's going to be a primary key. You need a primary key to work with the session extension. And then the other is going to be the person's age, and it's going to be an int. So once we're done with that, we can go .import CSV. We're going to give it the name of the file, so base.csv, and then the table that we want to import this into. And there we go. And if we look into our persons table, we have our 4 rows: Superman, myself, Batman, and Robin. And for those of you who know me, you'll know that I'm not 40, like the data implies. I am 35, and we'll use that mistake to our advantage. We're going to fix it and see what that does to reconciling divergent data. So now that we have our base state, let's clone this into A and B. Very easy. I'm going to say .clone A.db and .clone B.db. So let me switch now to A.db. So from now on, we're going to be person A, and we're going to do some modifications to our base data. So .open A.db. And let me think a bit, because I don't want to mess this up. OK, so now the first thing we're going to do is we're going to fix the mistake I made in my age. So we're going to set me back to 35 years old. So I'm going to say, while I'm in A.db, I'm going to say update persons set age equals 40, where age equals 35, and the other way around. Set age to 35, where age is 40, and just make sure that we're good. There we go. I am now 35. Demo complete. You can all go home. No, just kidding. So the next thing I'm going to do is, now that I've performed one change, so fixing an age in A.db, I'm going to go to B.db, and I'm going to do another change, and then we're going to reconcile them. So .open B.db, I am now person B, and let's confirm that. Select star from persons. And you'll see that in B's version, I am still 40 years old. And on this side, what we're going to do is we're going to make everyone 50 years old, but we're going to do that while the session and extension tracks our changes. So the way we do that, very simple, .session. And if I just do this and hit enter, it's going to tell me everything I can do. So it's fairly, easy to use. So first thing I'm going to do is I'm going to open a session. .session, open, main. Main is just the default schema name, so I didn't create any. We're still in main. And then arbitrarily, I'm going to call this my session. And we're now ready to perform tracked changes. So update persons, set age to 50. Just make sure we're still good. Star from persons. Everyone is now 50 years old, so now I can dump my change set. I'm going to do .session change set changes from B. And you'll see on the left, I now have a new file called changes from B. Let's Control Z out of this and maybe cat changes from B, see what's in there. And you'll see that it's binary data. It's kind of garbled. It's not meant for human consumption. So now that we've done this, let me close the CLI. And now we're going to apply the changes from B to changes from A. And we're going to see how we can merge the conflict that will occur. Now, the CLI does not expose the necessary APIs to do this. So I've had to vibe code a little program that will let me do this interactively on the CLI, just so we get a nicer demo. But in a real-world application, your application would be in charge of doing this through either the C API or your language's bindings to SQLite. So my little program is called interactive change set, and here's how you use it. We're going to say interactive change set. We're going to apply to a.db, and what are we going to apply? The changes from B. And as soon as I hit enter, if I did everything correctly, yeah, we get a conflict. It's saying, wait a second, I'm not sure what to do about this because it used to be 40 years old. One guy changed it, or you changed it to be 35, and the other changed it to be 50. What do you want me to do? So really, it's exactly like git merge. You get to choose which one you want. In this case, just for the sake of the demo, I'm going to choose omit. And there we go. If we go SQLite 3 a.db and look at what's in our table now, we see that our changes and the changes from B was everyone is now 35 was correctly merged with the changes from A. The changes from A being Mikaël is now 35. Excuse me, everyone is 50, Mikaël is 35. Merge complete, and that's how you synchronize databases using the session extension. What I've shown here is just scratching the surface. The documentation is very well written, and it has some advanced functionalities. So if you're interested, then please go and have a look at the documentation. It's super well written. Awesome. Now that we've seen these nice 3 extensions, I want to talk about 2 other extensions that are built by the SQLite team. We're not going to have time to look at them today, but I find them very interesting. First one is called zip file. It allows you to query, create, or modify files inside zip archives. And the first time I played with it, I thought it was mind-blowing. So you perform a select on a zip file, and you get a table, a virtual table, where each row represents either a directory or a file inside your archive. More interestingly, you can even you even have access to the data inside each of those files, and you can update directly through an update statement the files that are inside your zip archives. There's another extension called spellfix. It allows you to do spell checking from SQLite and has some pretty advanced functionalities like do a search by words that sound like something. So if you're interested, I encourage you to look at the documentation. It's very well written. So now that we've looked at these extensions, since this is an open source conference, I want to take the time to look with you at all of the nebula of projects and communities that surround SQLite, so all of these open source communities. And what I did was I tried to find everything I could get my hands on, every project that had at least 10 contributors, and I divided them into 5 categories. And I want to go through them with you. Some of those things I find are really interesting, and they're a testament to the community that SQLite managed to build. First category is forks and rewrites. The two projects in there are headed by a company called Terso, and disclaimer, I am a contributor to the second of these projects. So the first one, libsql, is a fork of SQLite. It does vector search, client-server mode, replication. It allows you to define functions in WebAssembly. It has around 150 contributors and 16,000 stars on GitHub, whereas Terso is a rewrite of SQLite in Rust. It adds vector search, materialized views, encryption, concurrent writes, change data capture, and many more. It also has around 150 contributors and 14,000 stars. Moving on to editors, SQLite Studio is SQLite-specific graphical editor. It has some nice SQLite-specific functionality, such as registering custom functions in either JavaScript, TCL, or SQL directly from the GUI. It allows you to drag and drop between databases, and it has plugins for extensibility. PHP-Lite Admin is a management dashboard for SQLite. It supports 15 human languages. It supports visualizations such as bars, pies, or lines, and it allows you to register custom functions, this time in PHP. And then finally, and this is the most impressive project I find of those three, is Dataset. It's an advanced tool for dataset visualization and publication. It allows you to easily navigate complex datasets in a web interface. It does automated faceting, which means that if you have, for example, a denormalized data set where a row contains strings and there's only maybe 2 or 3 distinct strings, then you can automatically extract a join table from that, and it's going to become a clickable link in the web interface. It allows you to publish templatable websites so that other people can see the results of your visualizations, and it has over 150 plugins. Replication. LiteFS is a fused file system, meaning it's a user space file system that will sit between your application and the kernel. It will capture and replicate transactional rights to the SQLite database. So its replication in that way is going to be completely transparent to both SQLite and your application. CR SQLite allows you to add replication capabilities to SQLite using conflict-free replicated data types, or CRDTs, whereas RQLite, by far the most advanced of those projects, is a distributed database based on SQLite, where each node of the database is going to be an SQLite instance, and they're going to coordinate amongst themselves using a Raft consensus algorithm. So in other words, you have a high availability SQLite database. CLIs, Q, text as data, allows you to easily and frictionlessly perform SQL over CSV directly from the CLI, and it's backed by SQLite. SQL ELF did not fit into my 10 contributors criteria, but it was so original and powerful that I could not omit it. It allows you to query symbols inside ELF executables. ELF executables is the executable format in Linux. So it's an alternative to tools like objdump, nm, and readelf. Now, Lightstream is a backup and recovery tool. It allows you to back up your database to things like S3, and it works by watching the changes to your write-ahead log, which is similar to bin log in MySQL, if you've worked with it. And then last but not least, the last one that I identified is called SQL Torrent. It's a VFS extension, meaning that it works by swapping out the storage layer inside SQL, and it allows you to perform queries while a database is downloading as a torrent. And the way it works is that each time you do a query, it's going to look at the byte ranges that are required to satisfy that query, and it's going to prioritize downloading those byte ranges in your torrent. So this concludes the overview of the open source projects around SQLite. There's many more, but they're smaller. They have less contributors. So please don't take this as this is all that exists. I hope that in my talk I gave you a good overview of what you can do with SQLite beyond simple CRUD queries. We looked at vector search, HTTP queries, synchronizing databases. We mentioned, unfortunately, we didn't have time to play with them, extensions to work with zip files, and what was the other one? Spell checking, and then we finished by this overview of open source projects. What I want to leave you with is, well, first, here's a QR code to everything I discussed today. So the code for my demos is in there, and the links for all of those open source projects is in there. And then at the center, I told you at the beginning that SQLite is public domain. This is the text that stands in lieu of a license in the SQLite source code files. They call it the SQLite blessing. I think it's a wonderful gesture from the SQLite team. It says, may you do good and not evil. May you find forgiveness for yourself and forgive others. And may you share freely, never taking more than you give. Thank you.
Hello? Okay. So if there are any questions regarding the lecture, anyone can stand up in front of the microphone in the middle and ask them for our Q&A section. Any volunteers? We even put a light on it. Okay, everyone's pretty shy or very tired due to the long day. So if there are no other questions, another round of applause for Mikaël. And thank you for coming.